Hi everyone, this is Salmandu and welcome to YÖS ALFA. Are you ready to test your skills and take one step closer to your dream university? Today we're bringing you the second free trial exam, a perfect chance to practice, improve, and get familiar with the rare YÖS exam format. If you haven't taken the exam yet, pause the video, check the description down below, and download the PDF. Try solving it on your own first before watching the solutions. This trial exam is designed to challenge you, help you identify your strengths, and pinpoint areas for improvement. So grab your pencils, clear your mind, and let's get started. Don't forget to like, subscribe, and turn on notifications so you never miss our future updates and practice exams. Let's dive in. Number 1. Ahmed writes the symbols of any two of the operations, addition, multiplication, and subtraction, inside the boxes below. After performing the operations, he writes all the results he obtains on a piece of paper. Accordingly, what is the largest result that he can get? So we're asked to find the maximum of this operation. How do we maximize it? Since we have two negatives, we can use multiplication to get the maximum result of the operation between the two, and for that we can use addition. So the result is going to be 27 plus 1, 28. It's A. 2. For a natural number A, the sum of the largest and the smallest natural numbers between a plus 3 and a plus 15 is 50. What is the value of A? Let's say x is any number between a plus 3 and a plus 15, and we're given that the sum of the smallest x and largest x is 50. So the smallest possible value for x is larger than a plus 3, so it is a plus 4. For the largest possible value of x, it has to be less than a plus 15, so it is a plus 14, and the sum is 50. So we can solve this equation to find the value of a. So 50 minus 18 over 2 is A. So this is 32 over 2, which is 16. So the answer is B. 3. A mathematical modeling is designed in such a way that the sum of the numbers written above the boxes represents the number written inside the respective box. Accordingly, what is the value of A? So we're given the sum being equal to the number written in the box. So this is simply two equations, two unknowns problem. We'll write down the first equation. 4 plus x plus y is equal to 23. X plus y is equal to 19. And the second equation is 2x plus y is equal to 30. And we're asked to find a, which is equal to 2y plus x. So we'll solve these equations to find x and y, and we'll substitute those values into this equation to get the answer. Let's subtract the two equations. So we have minus x is equal to minus 11. Thus, x is equal to 11. Plugging in x is equal to 11 into the first equation, we have 11 plus y is equal to 19. From here, y is 19 minus 11, which is 8. So we can find a by substituting these two values into the unknowns here. 2 times 8 plus 11 is equal to 27. So the answer is E. 4. A and B are defined this way. Accordingly, what is the value of this? So all we have to do is substitute these values into the expressions given above. So when a is 2, a cubed is 8. When b is 7, the result of the operation is minus 28. So we are asked to find 8 minus 28. So the result is going to be 36. How many two-digit natural numbers a, b are there where a and b satisfy the given inequality? Since a is a natural number and larger than 2, is going to start from 3, and it could also be 4, it could be 5, it could be 6, can it be 7? If A is 7, then B has to be 8. Since B is less than 8, A cannot be 7. So we have 4 different values of A. So we're going to start writing down the ABs. Let's start with A is equal to 3. If A is 3, then B can start from 4. So 34 is okay, 35 is okay, 36 is okay, 37, and 38. 38 is not okay since B has to be less than 8. If A is 4, then B can start from 5 since B is larger than A. So we have 45, 46, 47, and that's all. If A is 5, then we have B starting from 6, so 56, 57, and that's all. If A is 6, then B has to be 7 only. So how many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 numbers altogether. The answer is A, 6. What is the result of the operation? Let's simplify this. Since we have half in different forms, we're going to collect the terms, all the terms on the denominator. We already have half cube on the denominator, and half to the minus 1 is on the numerator. And since this is a division, we can send this to the denominator, and we have half squared. Simplifying this, we get half to the 6, the whole power half, which is equal to 1 over 2 cubed. So the answer is 8. E. 7. Given this expression, what is the value of x? So 25 to the x is the common factor of these two expressions. I'm going to take this out. So we have 1 plus 25 in the parentheses. And on the denominator, we have the common factor 5 to the x. So we can take this out of the parentheses, and we have 7 plus 5 minus 5 squared is 25. So this is 5 to the 2x, this one is 5 to the x, and 26 over, this is 12, and minus 25 is minus 13. Simplifying this, we have 5 to the x minus 2 times minus 2. This expression is given to be this one. This is nothing but 10 to, okay, minus 10, yeah, minus 10. So we have minus 5 to the x is equal to minus 5. So since the minus cancel out each other, since the bases are the same, we can 5 to the x is equal to 5. So x is 1. Number 8. What is the solution set of this equation? To find the solution set, we have 3 cases here. The first case is when the power is equal to 0. X squared minus 4x plus 3 is equal to 0. When the power is 0, then we're going to have 1, whatever the base here is, except for 0. The condition here is x squared minus 10 must not be 0. Because if we have 0, then we're going to have 0 to the 0, which is undefined. So let's solve this. So we have x minus 3 times x minus 1 is equal to 0. From here, x is equal to 3, or x is equal to 1. So let's substitute these values here and check if we have 0. If we have 0, then we're going to have to eliminate that number. So let's say x is 3, then, okay, 9 minus 10 is not 0. This is okay. When x is equal to 1, we have minus 9, again, not equal to 0. So both of the solutions here are okay. Okay, case 1 is checked. Case 2, when the base here is 1, then whatever the power is, we're going to have 1 here. So let's solve for this equation. X squared is equal to 11. From here, we have x is equal to plus or minus square root of 11. And we also have case 3, when x squared minus 10 is equal to minus 1, provided that x squared minus 4x plus 3 is an even number, because minus 1 to the even number is always 1. So let's solve for x first and check if it is even. So x squared is equal to 9. From here, we have x is equal to plus or minus 3. Let's check minus 3 first. When x is equal to minus 3, we have 9 plus 12 plus 3, which is 24. So it's an even number. It's checked. When x is 3, we have 9 minus 12 plus 3 is equal to 0. Since minus 1 to the 0 is also 1. So this part is also okay. So our solution set is going to be 3, 1, plus or minus square root of 11, and minus 3 here, since plus 3 is already counted. So our answer is E. Write it down this way. The whole square is equal to 3. So this expression is nothing but this. So now we have this square and that square root canceling out each other. Root x is equal to 2. From here we have x is equal to 4. Now, for the second part, since I have y and 2, I'll factorize this to 2 and y. So I can write it down this way, root 2 plus root y, the whole square, which is nothing but the whole thing here. And I'll have the square root on top, which is equal to square root of 8. Squaring both sides will give me root 2 plus root y, the whole square, is equal to 8. I will take the square root of both sides to get root 2 plus root y is equal to root 8, which is nothing but 2 root 2. Simplifying this, we have root y is equal to 2 root 2 minus root 2, which is root 2. So from here, we have y is equal to 2. So we have x and y. So we can write this expression as square root of 6 and square root of 6 and square root of 6, the recurring roots. And to solve this, let this expression be k. Let's square both sides of the equation. So we have this is equal to k squared, and this thing over here is nothing but the expression here, which is again k. So I can substitute k instead of this one. So 6k is equal to k squared. From here we have k is equal to 6. Remember, k is what we have been looking for the whole time. So our answer is 6. Number 10. What is the result of this operation? Since we are adding up the two fractions, we should have the common denominators. So since here we have positive and here we have negative, how do we find the common denominator for these two? We can find the common denominator by multiplying this by x minus square root of 3 plus x squared. Since we are multiplying the denominator by this expression, we should also multiply the numerator by the same expression. For the second denominator, I'm going to do the same step, just like this. Since we have negative, we'll multiply this by positive. So we have the common denominator. I'm also going to multiply the numerator by the same expression. So we have x minus square root of 3 plus x squared plus x plus square root of 3 plus x squared on the numerator. On the denominator, when we multiply these two, we have x squared minus 3 plus x squared. Okay, and the whole expression is equal to be 2. So simplifying this, we have this and that canceling out, and this and that canceling out. So the result is going to be 2x over minus 3 is equal to 2. So x is minus 3. Number 11. We will cross multiply these two. So we have 4ab is equal to a plus b, and we're going to divide both sides of the equation by ab. So we get 4 is equal to 1 over b plus 1 over a. We'll cross multiply this equation again. 5bc is equal to b plus c, and we're going to divide both sides of the equation by bc. So we get 5 is equal to 1 over c plus 1 over b. From the third equation, we do the same procedure. So we have 6ac is equal to a plus c, and we will divide both sides of the equation by ac. So we get 6 is equal to 1 over c plus 1 over a. From here, we have 1 over a twice, and 1 over b, 1 over b, and 1 over c, 1 over c. So when we sum them up, we have twice 1 over a plus 1 over b plus 1 over c is equal to 15. And we're asked to find c. And we know that 1 over a plus 1 over b is equal to 4. From here, we have 15 over 2 minus 4 is equal to 1 over c. 15 minus 8 over 2 is 1 over c. So from here, we have c is equal to 2 over 7. The answer is D. Number 12. From the first equation, we can write 2 to the 25 is equal to 3 plus a. From the second equation, we can write 2 to the minus 23 is equal to 1 minus b. When we multiply these two equations, we have 2 squared is equal to 3 plus a times 1 minus b. And we're asked to find b in terms of a. So I keep b on one side of the equation, and I will write it this way. 3 plus a over here. So b is going to be 1 minus 4 over 3 plus a. So 3 plus a as the common denominator, and we have 3 plus a minus 4. The result is a minus 1 over a plus 3. So the answer is B. 13. A and b are positive natural numbers. According to the division without the remainder above, the sum a plus b is always divisible by which of the following? So from here, we can write down the relation, the multiplication of the divisor and the quotient plus the remainder is equal to the dividend. From here, we have 2ab plus 2b is equal to a squared plus 2b. 2b's cancel out each other, and we have 2b is equal to a. And we need to find a plus b. Since a is 2b, a plus b is 3b. And 3b is divisible by which of the following? It's 3. Number 14. This expression is given, and we're asked to find x plus y. So let's simplify this. Since we have 10, I'm going to change this to 2 over 10. So we have 10 to the x plus y times 10 is equal to 10 to the x plus y plus 1. And we have 3 to the minus x times 2 to the, this is 1, this is y. So you have y plus 1 over here. And 6 to the x can be written as 2 to the x times 3 to the x. So we have 10 to the x plus y plus 1 is equal to 3 to the x minus x times 2 to the x from here, and we have y plus 1 over here. This is 1. So we have the powers x plus y plus 1 equal on both sides, but the bases are not equal. So to satisfy this condition, the only possible thing is x plus y plus 1 must be 0. So from here we have x plus y is equal to minus 1. The answer is C. Number 15. According to this equation given, what is the ratio of a plus b over b? So we will solve this equation. We'll cross multiply them. We have a squared b minus a is equal to, since we have a minus 4 here, a plus 4 there. So the multiplication of these two will be a squared minus 16 times b. So a squared b minus 16b is equal to a squared b minus a. A squared b's cancel out each other. We have a is equal to 16b. So let's substitute this a in this expression. 16b plus b over b is what we're looking for. So the result is 17b over b. It's 17. 16. This ratio is given. Accordingly, what is the value of b? And the first thing we notice is the proportionality constant over here and here are identical. That means we can change this form to that form by multiplying 3. So if you multiply 3, you should also multiply the denominator by the same number. Since we have minus 4c, we will multiply the numerator by minus 4 and denominator by the same number. Now, if we sum up the two numerators and the two denominators and take the ratio, we know that the ratio is going to be the same as before. So that means 3a minus 4c over 3b minus 4d is equal to p. So 3b must be equal to 5 from here, so b is 5 over 3. And this is what we are asked. So the answer is A. 17. In the figure, AE is parallel to DC. ADC is equal to 20. EAD is equal to DAC. It's given here. AE, CD, and BC are also given to be 2, 6, and 4. Respectively. So BC is 4. I'm going to add this. Angle EBC is asked. So we'll start from here. Since CDA is 20 and CD and AE are parallel, so we have 20 over here too, because they are alternate angles. This is 20, and that is also 20. Now we have the isosceles triangle over here. This side is 6, so AC should also be 6. Since we already have BC is equal to 4, AB is 2. So now we have another isosceles triangle. AB is 2, AE is 2. So these two angles must be the same. Since we have 40 over here, this is 70, and that is 70. From here, we have theta plus 70 is equal to 180, and theta is 110 degrees. So the answer is D. In the figure, FD is parallel to AC. These two lines are parallel. BF is a bisector. It's given in the figure already. This line is a bisector. And BD is also another bisector, as given in the figure. And ED is 6. So ED is here, and it's 6. Accordingly, what is the value of FD? So the length from F to D is asked. So we need to find out FE. If we find out FE, then we can get the answer, FD. So let's start from here. Let's say this angle is theta. This is also theta. Let's say this is alpha, so that's also alpha. So the summation of all these angles is 2 theta plus alpha is equal to 180 degrees. From here, we have theta plus alpha is equal to 90. So this is the 90 degrees. And we also need to make use of this, FD parallel to AC. So if this is theta, that's also theta. They are alternate angles. And from the right side, if this is alpha, this is also alpha. Again, alternate angles. So now we have alpha over here and alpha over there. So this is an isosceles triangle. So if this is 6, that's also 6. In the triangle FEB, we have the same thing going on here too. We have theta and we have theta over here. So this is also an isosceles triangle. These two sides must be the same. So FE is going to be 6. So we're asked to find FD. So the answer is going to be 6 plus 6, which is 12. So the answer is B. 19. In the triangle ABC, AB is equal to AC and AD is equal to AE. This side and that side are the same. And EDC is 10 degrees. What is the measure of angle BAD? This angle is asked. So we have two isosceles triangles here. If this is alpha, that is also alpha. And we have another isosceles triangle over here. So if this is delta, that's also delta. Let me not use the different unknowns and just use this, because we know that this angle is tan plus alpha. The summation of two interior angles of a triangle is always the same as the exterior angle. So since we have an isosceles triangle here, angle E and D are the same. So in the triangle ABD, the summation of alpha and theta is the same as the exterior angle. So I'm going to write down this equation. Theta plus alpha is equal to tan plus alpha plus 10. From here, alphas cancel out each other. We have theta as 20. So the answer is B. Number 20. ABC is a triangle. AD is equal to DB. It's given in the figure. DEC is equal to ACB. It's also given in the figure. BC is 8. According to the information given, what is DE in the figure? Let's say this is X. So we'll try to make use of the similarities of triangle, because D is the midpoint of AB. Let me draw a line parallel to the base of the triangle BC. And let's say the length of this line is Y. We can find out what Y is by taking the similarity ratio of the two triangles, the smaller triangles and the larger triangle. They are similar. So Y over 8 is going to be AD over AB. It's 1 over 2. From here, we have Y is equal to 4. And we haven't used these two angles being equal yet. So let's say this is theta, that's also theta. And since these two lines are parallel, this is also theta. They are corresponding angles. So now we have the two angles equal here in this smaller triangle. So since the two angles are equal, this must be an isosceles triangle with x is equal to y, which is 4. So the answer is E. Number 21. ED is a tangent. It's given in the figure. And AE is perpendicular to DC. It's also given here. And DF and FB are given to be 6 and 3. So what is BE? Given that O is the center of the circle. Let's say BE is X. So we'll first start from here. If a line is drawn from the center of the circle perpendicular to the chord, then we know that it divides the chord into two equal parts. If this is 6, that's also 6. And from the circle theorem, we also know that the multiplication of these two is the same as the multiplication of these two over here. Let's say this is y. So 6 times 6 is equal to 3y. From here we have y is equal to 12. If y is 12, then the radius of the circle is going to be, since this is 12, that is 3. So the diameter is 15. So the radius is 15 over 2, which is 7.5. Since we have 3 already here, so this length would be 4.5. Now let's draw a line from the center to the tangent point D. Since this is a radius and this is DE is tangent, we know that they are perpendicular to each other. So we're asked to find x, and we have 90 degrees here, and a perpendicular line drawn from D to F is also given. So we can use Euclid theorem. So 6 squared is equal to 4.5 times this, 3 plus x. So x is the only unknown in this equation, so we can find it easily. So this is 36. 4.5 is the same as 9 over 2. This is 3 plus x. 3 plus x is equal to 8. From here we have x is equal to 5. So the answer is A. ABCD is an equilateral quadrangle. Equilateral quadrangle is the same as rhombus, which means all four sides of the quadrilateral are equal, but it's not a square. And AE is equal to EB is equal to BF. So AE, EB, and BF are equal. Since all the sides of a rhombus are the same, BF must be equal to FC too. According to the information given above, what is the value of area ABCD? The entire area of the rhombus is asked. So let's draw a line from A to C. Since the ratios of BE and EA is the same as BF and FC, we can see that these two lines are parallel. So from the similarities of the triangle, let's say if this is x, we can take the ratio 15 over x as BF over BC, which is 1 over 2. From here, x is 30. We also know that the two diagonals of the rhombus are perpendicular to each other. Since x is, and they bisect each other. So x is 30, that means we have 15 over here, we have 15 over there. Since this is a right triangle, DC, let's say this is O. From Pythagoras theorem, we can see that this length is 8. So the area of triangle DOC is going to be half, let's say the base is 15, the height is 8. So this area is 60. And we know that in the rhombus, the four triangles have equal areas. So to find out the entire area ABCD, all we have to do is multiply this area by 4, since we have 4 equal triangles. So the answer is 240. Number 23, ABED is a quadrangle or quadrilateral. DEGF is a deltoid. This one is a deltoid. So let's draw this one first so that we can see better. I am drawing the deltoid, and I'm also going to fill out the properties of the deltoid in the figure. So we know that the diagonals of a deltoid are perpendicular to each other, and these two side lengths are equal. Okay, so what else is given? DE is parallel to AB, and these three sides are given in the figure, 6, 6, and 3, and the side length AB is asked. Since the two parallel lines are given, we will try to make use of the concept of similarity of the triangles. Let's draw a line from G to this point H and let it be parallel to the two sides DE and FB. So now we have triangles that are similar to each other. We'll start from these two triangles. These two triangles are similar, so we can take the ratio of their sides. Since the ratio of this side and that side is 1 to 1, so the ratio of this side and that side must also be 1 to 1. Since DE is 6, HG must be 6 too. Now let's move over to the second triangle, this one. And that triangle and this triangle over here is also similar to each other. So we can take the similarity ratio. 6 over 9 is equal to, this one is already 6, so this length FB must be 9. So now we have FB and AF equal. That's given in the figure. So if this side is 9, we also have this side also 9. Since we are asked to find AB, the length of AB is going to be 9 plus 9, which is 18. Number 24. According to what's given in the figure, what's y coordinate of A? So I asked to find this distance. So to find the coordinates of A, we need to know the equations of this line and that line. And point A is the intersection of the two lines, meaning that the coordinate of A is the solution of the two equations given here. So we'll first find the equation of this line. And the slope of this line is rise over run. So since the rise is 2, the run is 4, and the line is going in this direction, we have a negative slope. 2 over 4 is negative half, and x plus, when x is equal to 0, we have y is equal to 2. So we got the first equation. The second equation can be found using the same technique. So the rise is 3, run is 3, and since the line is going in this direction, it's a positive slope. So we have x plus, when x is 0, y is 3. So we have this equation. So since we are looking for the coordinate, the y coordinate of A, I'm going to substitute x from this equation to that equation and find out y. So half x is 2 minus y. From here, x is 4 minus 2y. And let's substitute this value over here. So y is 4 minus 2y plus 3. From here, we get 3y is equal to 7. Y is 7 over 3. So that's our y coordinate of point A. So the answer is C. Number 25. The distance between the center of the circle and the origin is 10. This distance is given to be 10. And what is the radius of the circle? So we're asked to find the radius. This is radius. Okay, so since this is 3 and that is 13, so that point is a midpoint between, this is the midpoint between A and B. So since this is 3, that is 10. 13 minus 3 over 2 is 5. So the length here is 5. The length there is also 5. So in this triangle, this is 8 and this is 10. So we can find this using the Pythagoras theorem. So this is 6. So from here we can find the radius of the circle as 6 squared plus 5 squared. So the radius is 36 plus 25 is equal to 61. So the answer is B. F of x is given. Which one of the following is f inverse of x? So let's say f of x is equal to y. From here we can say that x is equal to f inverse of y. So let's substitute these values. F of x is equal to y. So we have y is equal to 3 times y minus 2 over x minus 4. From this expression, if we can find y, then we get the value of f inverse. So x minus 4 is equal to 3y minus 2 over y. From here, x is 3y minus 2 over y plus 4. When we make the denominators equal, we have 3y minus 2 plus 4y. So from here, 7y minus 2 over y. So this x is nothing but f inverse of y. So from here, f inverse of x is going to be 7x minus 2 over x. Number 27. The function f of x is given. F of 1 is 4. F of 40 is asked. Since this is given, we're going to start from f of 1. From this function, f of 1 is going to be f of 2 minus 2 over 3. F of 2 is going to be f of 3 minus 2 over 3. F of 3 is going to be f of 4 minus 2 over 3. If you keep on going like this up until f of 39, we'll have f of 40 minus 2 over 3. So now I'm going to sum up everything from here up until f of 39. So this and that cancel out each other. So we have these things all cancel out each other. So we have f of 1 is equal to f of 40 minus 2 over 3 times, how many times do we have? From 1 all the way through 39, we have 39 terms of minus 2 over 3. So since f of 1 is given to be 4, f of 40 is 30. The answer is B. 28. This equation is given. F of minus 1 is asked. If we start from f of minus 1, this is going to be f of 1. Since we don't know f of 1, we can't figure out f of minus 1. So we need to first start with f of minus 1. F of 1. So let's start with f of 1. So if x, when x is equal to 1, we have f of 1 minus 3 times f of 1 is equal to 5 minus 1. From here, minus 2, f of 1 is equal to 4. F of 1 is equal to minus 2. So now we have f of 1. We can continue with f of minus 1. So x is minus 1. So we have f of 1 minus 3 times f of minus 1 is equal to minus 5 minus 1. So we have f of 1 is equal to minus 2. So minus 3 f of minus 1 is equal to minus 6 plus 2. From here we have f of minus 1 is equal to minus 4 over minus 3, which is 4 over 3. So the answer is E. Number 29. The roots of the equations are x1 and x2. Then this is asked. So this is going to be x1 minus 2, x2 minus 2 on the denominator, and we have x2 minus 2 plus x1 minus 2 on the numerator. Let's simplify this. We have x1 plus x2 minus 4 over x1, x2 minus 2x1 minus 2x2 plus 4. So we have x1 plus x2 minus 4 over x1, x2 minus 2 times x1 plus x2 plus 4. And let's say this equation is in this format. Then we know that x1 plus x2 is minus b over a. So in this equation, we have 6 over 2, which is 3. In the same way, we know that x1 times x2 is c over a, so 1 over 2. So we have all the ingredients we need for the final equation over here. So x1 plus x2 is 3, and x1 and x2 is half, and this is also 3. So when we simplify this equation, we have half minus 6 plus 4 is minus 2. From here, we have minus 1 over 1 minus 4 over 2. So the result is going to be 2 over 3. The answer is C. Number 30. This equation is given. Which one of the following is the polynomial p of x plus 2? So we're asked to find this. So to find a polynomial in terms of x, we need to find out m and n first. To find out m and n, we can make use of this. Let's say x squared minus 2 is equal to 0. Then we have x is equal to plus or minus square root of 2. Now let's substitute x is equal to root 2 to this expression. So we have 0 times whatever that is 0 is equal to x cubed. Instead of x cubed, since we are substituting x as root 2, we have root 2 cubed minus root 2m plus n. So this is our first equation. The second equation is going to come from x is equal to minus square root of 2. Let's substitute minus root 2 to this equation. We have 0 is equal to minus root 2 cubed minus root 2. Since we are substituting minus, it's going to be plus root 2m plus n. So now this is two equations, two unknown problems. Let's sum them up. This and that cancel out each other. So these two cancel out each other too. We have 2n is equal to 0 from here. N is 0. If n is 0, we can substitute it back into the second equation, and we have root 2m is equal to root 2 cubed. Let's cancel them out each other. So we have root 2 squared. So the answer is m is equal to 2. So now we have m and n. We can write down this equation again to find out p of x plus 2. X squared minus 2 times p of x minus 1 is equal to x cubed. Instead of m, we have 2, so minus 2x. Since n is 0, we don't have anything left. So this x cubed minus 2x is the same as x times x squared minus 2. So x squared minus 2 cancel out each other. So we're left with p of x minus 1 is equal to x. So we're asked to find p of x plus 2. So to get p of x plus 2, I'm going to equate this thing with x plus 2 and find out x. So x minus 1 is equal to x plus 2. That means x is equal to x plus 3. So now let's substitute this into this equation. So we have p of x plus 2 is equal to, since we are substituting x is equal to x plus 3, on the right hand side of the equation we have x plus 3. So that's our answer. 1. The simplified version of above expression is x plus 4 over x plus 2. What is the value of a plus b? So let's start from the denominator. Let's factorize it. So we have x minus 5 times x plus 2 on the denominator. And when we simplify this, we have this. So that means we don't have x minus 5 on the denominator anymore. So that means that we need to have x minus 5 on the numerator so that they cancel out each other and we don't see x minus 5 on the denominator anymore. So the next term on numerator is going to be x plus 4. So x minus 5, x plus 2 is as it is shown here. And on the numerator, we have x squared minus x squared plus 4x minus 5x minus 20. When we simplify this, we have x squared minus x minus 20. So these two expressions must be the same. So from here we get a is equal to minus 1 and b is equal to minus 20. So we are asked to find a plus b. So the result is minus 1 minus 20 minus 21. The answer is A. What's the result of the expression above? So let's simplify this. We have xy on the denominator. So on the numerator, we have x times x minus y minus x minus y times y. So for this expression, we have xy on the denominator and x minus y on the numerator. So when we simplify this, these two cancel out each other. And since x minus y is common in both expressions, I can take this out of the parentheses and we have x minus y times x minus y. So we also have another x minus y on the denominator. So the answer is going to be x minus y. It's D. Number 33. There is a relation between p of x and q of x as follows. This relation is given that remainder when the polynomial p of x is divided by x minus 2 is 5. So p of 2 is equal to 5. So this is given. What is the remainder when the polynomial q of x is divided by x minus 1? So q of 1 is asked. So let's start from q of 1. When x is equal to 1, we have p of 3 minus 1 is 2, p of 2 minus 3 minus 2 over q of 1 is equal to 1 minus 1 plus 2. Since p of 2 is known to be 5, so we have 5 minus 1 is equal to 2 times q of 1. From here we have q of 1 is equal to 4 over 2, which is 2. So the answer is C. Number 34. The graphs of this linear line, f of 2x minus 1 and g of x are given. We're asked to find this expression. So let's take this expression out of here and paste it over here. So let's start finding the value of this. So g inverse of f, the whole inverse of 2, let's say this is k, then 2 is equal to g inverse of f of k, which is the same as g inverse of f of k. From here, I'm going to send this g to the left-hand side of the equation again. So we're going to have g of 2 is equal to f of k. So g of 2, let's take a look at the graph. G of 2 is 7. So this is 7. And we want to find out k. So k is f inverse of 7. So f of 2x minus 1 is equal to y. From here we have f inverse of y is equal to 2x minus 1. So we'll ask to find f inverse of 7. So when y is 7, what is x? When y is 7, our x value is 2. So this x is 2. So 4 minus 1 is 3. Our f inverse of 7 is 3. So from here we have k is equal to 3. So this part is done. It's 3. How about this part? Let's calculate this one too. So I can simplify this way. G of f of g inverse of 9. So let's start from g inverse of 9. Do we know g inverse of 9? Yeah. Since g of x is y, g inverse of y is x. So g inverse of 9 means when y is 9, what is our x? When y is 9, our x is 0. So this one is 0. So f of 0, how much is f of 0? So f of 0 means the y value when x is half. So when x is half, what is y? So that's what f of 0 is. So when x is half, how much is y? So let's say this is half. We want to figure out what y value of the graph is. Okay, so I'll use the similarities of the triangle. So we have this triangle and that triangle. Since these two lines are parallel, we can use similarity of the triangles. So y over this length is 7. So y over 7 is equal to this over that. So this is, since it's half plus 3 over 2, it's 4 over 2, which is 2. So 2 over the whole thing, from 2 to 3 over 2. So this is 1.5. 2 plus 1.5 is 3.5, which is 7 over 2. So we have this, and this 7 and that 7 cancel out each other. So we have y is equal to 4. And that's what we're looking for. So f of 0 is 4. So we're left with g of 4. What is g of 4? When x is equal to 4, what is y? So that's the definition of g of 4. So since when x is equal to 4, we have y is equal to 0. Our result is going to be 0. So this part is 0. And that part is 3, so our answer is going to be 3. Number 35. If x is as given here, what is the sum expression above? This one is asked. So when we check these two expressions, we see that the denominators are the same on both sides, here and there. So we can simplify this expression as 1 plus 2 over 31. For this expression, we have 25 over here, and 25 times 3 is 75, and what's left is 7. So 7 over 25. And for this one, we have 13 times 4 is 52. So it's 3 over 13. So when we compare these two, we see that we have this 2 over 31, 7 over 25, and 3 over 13, which is x here. So we're going to be left with the summation of these three, which is 8, and what's left is x. So the answer is 8 plus x. It's D. Which one of the following is the result of the operation above? The operation is given here. So we have repeating decimals here. So 0.12 bar is the same as 0.12, 12, 12, and this 1/2 part is repeating. So how do we convert this to fraction? We can do it this way. Let's say this is x. So 100x is going to be, if we multiply this expression by 100, we have 12.12 bar. So now let's subtract this two. 100x minus x is 99, and 12.12 bar minus 0.12 bar is 12. From here we have x is equal to 12 over 99. Let's make the simplification by dividing both denominators and numerators by 3. So we have 4 over 33. And for 0.15 bar, let's do the same procedure. Let's say this is y. So 100y is going to be 15.15 bar. Now let's make the subtraction. 99y is equal to 15. From here we have 15 over 99. Let's make the simplification. We have 5 over 33. Now let's substitute x and y back into the given expression. So we have 4 over 0.12 bar is 4 over 33 plus 5 over 0.15 bar is 5 over 33. So these and that cancel out. So our result is going to be 33 times 2, which is 66. So the answer is B. 37. X is between 0 and 1. In this expression, find x. So this is a geometric series with common ratio x. So the first term is a, which is 1. The common ratio is x. And since x is between 0 and 1, we can use the infinite sum formula, which is a over 1 minus r. So a is 1 and 1 minus the common ratio is x, and the infinite sum is given to be 5. So from here we can find x. So 1 is equal to 5 minus 5x. From here 5x is equal to 4. X is 4 over 5. The answer is D. In the figure above, the graph of the parabola f of x is given. AOCB is a square, and the area of this square is asked. From this function, when x is 0, this is 0, that is 0, so y is going to be 3m. So this point is 3m. Since this is a square, if this length is 3m, that length is also 3m. So the coordinate of this point A is negative 3m. Now let's substitute this into the function f of x. So f of minus 3m is going to be this, which is 3m. So f of minus 3m is 9m squared plus m plus 4 times negative 3m plus 3m is equal to 3m. So from here, this and that cancel out each other. We have 9m squared minus 3m squared minus 12m is equal to 0. 6m squared is equal to 12m. From here, m is equal to 2. So the area is 3m times 3m, which is 9m squared. Since we know m is equal to 2, the answer is going to be 36. It's B. What is the multiplication of the roots of above equation? To find out the roots, we need to solve for this equation and find the x values, and we need to multiply the x values that we find. So since we have x minus 3 over here, we can somehow manipulate this expression so that we have x minus 3 over here again. So let's take out the common factor minus 3 of the parentheses. So we have x minus 3 left inside the parentheses, and we can write it this way. So this negative 3 is going to be 3, and what's left is x minus 3 over here, and this negative is over here. So x minus 3, let's assume that x minus 3 is y. So we have this equation, y squared minus 3y minus 10 is equal to 0. When we solve this, we have y is equal to 5 or y is equal to minus 2. Since y is an absolute function, the smallest possible value of y is 0. So negative is impossible. So we'll solve for this y is equal to 5. So x minus 3 is equal to 5 if x minus 3 is positive. If it is negative, we have x minus 3 is equal to minus 5. From here, we have x is equal to 8 or x is equal to minus 2. So we have these two values since the question asks the multiplication of the roots. So the answer would be 8 times minus 2, which is minus 16. The answer is C. 40. X cubed minus x minus 3 is equal to 0 given, and this expression is asked. So let's multiply these expressions and write down the equation one more time again. So x cubed plus x minus x squared plus 3x minus 4x plus 28 plus 1. So this is x cubed plus x squared. This and that cancel out each other. X cubed from here is going to be x plus 3. So this is x plus 3. And we have minus x from here plus 29. So minus x and plus x cancel out each other. And the answer is 32. So it's D. This is the end of the math part of the second trial exam. For IQ part, see you in the next video.